For centuries, Stonehenge has stood as one of the greatest mysteries in human history. Generations of scholars, engineers, and archaeologists have tried to understand how it was built, what its true purpose was, and how people living 5,000 years ago could have created such a remarkably complex monument. In 2026, researchers decided to approach the mystery from an entirely different direction. Instead of relying on traditional archaeological theories, they fed every piece of Stonehenge data accumulated over centuries into Grok AI, an artificial intelligence system designed to detect patterns that human researchers may have overlooked. What Grok uncovered within that vast archive was not a simple answer. Instead, it revealed a network of patterns and relationships that scholars have debated for generations, while raising an even larger question about the true nature of Stonehenge itself. Stonehenge rises from the Salisbury Plain, about 90 miles southwest of London. For centuries, humanity has wrestled with a fundamental question. How could people living 5,000 years ago, people believed to possess no advanced mathematics, no written records, and no sophisticated tools, create a monument displaying a level of engineering precision that would require knowledge not formally documented until thousands of years later? When serious investigations began in the 17th century, researchers could offer little more than speculation about its origins. Was it a Celtic temple, a Roman construction, a Druid ceremonial center, an ancient observatory? What we see today is a monument composed of massive sarsen stones, arranged in a circle, many connected by horizontal lintels. Inside this outer ring stand smaller blue stones placed in patterns whose logic has resisted every attempt at explanation. The largest sarsen stones rise more than 20 feet high and weigh approximately 25 tons each. They were quarried from the Marlborough Downs, about 20 miles to the north. The blue stones, though smaller, still weigh up to 4 tons and originated in the Preseli Hills of Wales, roughly 140 miles away. According to conventional models of Neolithic society, transporting and erecting stones of this scale should have been extraordinarily difficult. Construction unfolded in multiple phases between 3000 BC and 2000 BC. The earliest work involved digging a circular ditch with an internal earth bank. Next came the Aubrey holes, 56 mysterious pits arranged in a ring whose purpose remains debated. Later, the enormous sarsen stones were positioned and raised into place. Finally, the blue stones underwent several periods of rearrangement into configurations that archaeologists are still trying to understand. The standard explanation is straightforward. Neolithic communities, motivated by religious devotion, periodically gathered to build this monument. They moved the stones using wooden rollers and ropes. They raised them with earthen ramps and human labor alone. Their astronomical alignments were achieved through generations of observation and persistent trial and error. Then, around 1600 BC, the site was abandoned for reasons that remain unclear, leaving it to time and mystery. Yet, this is the point that has long troubled engineers and physicists. Even with modern machinery, moving and positioning a precisely shaped 25-ton stone presents significant challenges. Without cranes, metal tools, or wheeled vehicles capable of supporting such weight, the task appears to push the limits of physical feasibility. So, when a series of breakthrough findings emerged in 2026, revealing not only how these stones may have been positioned, but also what the entire structure may actually have done, the scientific community fell silent. The discovery came through Grok AI, the advanced artificial intelligence system developed by XAI. Researchers assembled every measurement, archaeological survey, geological analysis, and astronomical calculation ever conducted at Stonehenge. The result was a dataset containing petabytes of information gathered across more than 3 centuries of research. This vast archive was fed into Grok's neural network, which had been specifically trained in physics, engineering, astronomy, archaeology, and pattern recognition using enormous historical databases. Grok received a simple instruction: analyze all available Stonehenge data and identify patterns, purposes, and principles that human researchers may have missed. What it returned was not a single answer. It was a complete reinterpretation of what Stonehenge is, how it functions, and what knowledge may have been required to create it. This is where everything changed. Grok's initial analysis focused on the Aubrey holes, the 56 pits surrounding the stone complex that have puzzled researchers since their discovery in the 17th century. For centuries, archaeologists proposed that they were cremation pits, structural post holes, or ceremonial features. Grok identified something entirely different. The AI analyzed the precise spacing between the Aubrey holes using compiled survey data measured to the millimeter. What it discovered shocked the research team. The spacing was not uniform. The holes were not distributed evenly around the circle. For decades, scholars attributed these variations to measurement error or imperfect construction, the expected result of Neolithic builders working with simple tools. Grok demonstrated the opposite. The AI found that the spacing variations followed a mathematical pattern. When the distances between consecutive Aubrey holes were plotted on a graph, the result was not random scatter. It formed a curve. More specifically, it formed a sinusoidal pattern matching the equation that describes changes in the Moon's orbital motion during its 18.6-year nodal cycle. Consider what that implies. The variations in spacing encoded the maximum and minimum lunar declination angles as the Moon moved through its 18.6-year cycle around Earth. This represents advanced lunar astronomy requiring decades of systematic observation, mathematical analysis, and the ability to convert those calculations into physical measurements, accurate to within inches across a circle more than 300 feet in diameter. Dr. Jennifer Walsh, an astronomer invited to verify Grok's findings, stated in her report, "The correlation between Aubrey hole spacing and lunar orbital mechanics is statistically overwhelming. The probability of this pattern occurring by chance is effectively zero. Someone 5,000 years ago understood lunar mechanics at a level not formally achieved until Kepler's work in the 17th century, and encoded that knowledge into the physical spacing of 56 holes cut into the chalk bedrock." But Grok discovered something even more subtle. The AI analyzed not only the spacing, but also the total number of holes, 56, and identified why that specific number may have been chosen. 56 was not arbitrary. It closely corresponds to 3 complete lunar nodal cycles. Multiply 18.6 by 3, and the result is 55.8, effectively 56. This suggests that the Aubrey holes functioned as a 3-cycle lunar calculator, allowing observers to track and predict the Moon's position across a 56-year period. Modern astronomers rely on computers and centuries of accumulated observational data to calculate lunar orbital mechanics with high precision. The builders of Stonehenge appear to have encoded those calculations into holes dug with antler picks 5,000 years ago. How they translated such complex calculations into measured spacing remains unknown. Grok could not answer that question, but it could demonstrate that the knowledge itself existed, preserved within the monument's physical design. Yet, the AI analysis of the Aubrey holes was only the beginning. Grok next turned its attention to the sarsen stones themselves, the massive trilithons that form the iconic structure we recognize as Stonehenge. The AI examined every available measurement relating to stone placement, orientation, and alignment within archaeological databases. What it discovered fundamentally transformed our understanding of what Stonehenge may have been designed to do. The sarsen stones were not placed solely to mark the summer solstice sunrise, as long believed. Grok's algorithms detected something far more complex. The stones created what modern physics would describe as a resonant chamber, a 3-dimensional space engineered to manipulate sound waves in specific ways. The AI analyzed the spacing between stones, the height of the uprights, the placement of the lintels, the curvature of the circle, and the density of the sarsen material. When acoustic simulations were run using these variables, the results were astonishing. Stonehenge, when complete with all stones and lintels in place, would have functioned as a sophisticated acoustic instrument. Its arrangement generated standing waves at specific frequencies, particularly within the range of 95 to 120 Hz. Modern research has shown that exposure to sound frequencies within this range can influence human perception and physiology. Studies have documented altered states of awareness, intense emotional responses, visual disturbances, changes in heart rate, and shifts in neural activity associated with trance-like experiences. According to Grok's simulations, the builders of Stonehenge may have intentionally designed the monument to generate precisely these effects whenever sound was produced within the stone circle. Bandich Tiep Theo. Dr. Marcus Chen, an acoustic engineer who verified Grok's model, said the precision required to produce these acoustic effects was extraordinary. To achieve this, one would need to understand wave mechanics, resonance principles, and the relationship between physical dimensions and sound frequency. Modern acoustic engineers use advanced mathematics and computer modeling to design spaces with specific sound properties. Stonehenge achieved a comparable result using nothing but carefully positioned stones. But this is where the story becomes unsettling. Grok found that the acoustic properties changed depending on where a person stood inside the circle. The AI identified specific locations, nodes within the sound field, where the infrasonic effects would have been most intense. These locations corresponded precisely with the areas where cremated human remains have been discovered. They were not random burials scattered across the site, but deliberate placements at points of maximum acoustic intensity. Consider what this suggests. People standing or sitting in these specific positions during rituals involving drums, chanting, or other rhythmic sounds would have experienced the most powerful consciousness-altering effects of the monument's acoustic properties. Some people died there. Whether this happened from natural causes during profound ritual experiences or from the physiological effects of intense infrasound exposure, we cannot determine. But Grok's analysis makes one thing clear. Stonehenge was not a passive temple. It was an active technology designed to influence human consciousness through sound. The AI's analysis of the bluestones revealed another layer of sophistication that researchers had completely overlooked. These smaller stones, transported 140 miles from Wales, were not chosen at random. Grok analyzed the geological composition of each bluestone using petrographic surveys and mineralogical data from the database. What it found was that the bluestones had been specifically selected for their acoustic properties. When struck, bluestones produce a clear ringing sound, and different stones generate different pitches depending on their size, shape, and mineral composition. Grok's algorithms found that the bluestones at Stonehenge were not randomly chosen from Welsh quarries. They were selected to create a harmonic sequence, a set of sounds connected through precise mathematical ratios, forming what musicians would recognize as a musical scale. The AI determined that if the bluestones were struck in their current positions, in sequence, they would produce tones forming a pentatonic scale, the same five-note scale found in musical traditions across cultures around the world. This was not coincidence. It suggests the deliberate selection of stones through acoustic testing, the transport of specific stones over 140 miles, based on their sound-producing qualities, and the arrangement of those stones to create musical relationships. But then Grok found something even more remarkable about the bluestone arrangement. The AI analyzed the positions of the bluestones in relation to the sarsen stones, and determined that they had been placed at specific acoustic nodes, locations where they would interact with the infrasonic resonance generated by the sarsen circle. When the sarsen stones produced infrasound, the bluestones placed at these nodes would have vibrated sympathetically, creating additional harmonic frequencies that enhanced and modulated the overall acoustic environment. This is acoustic engineering of astonishing sophistication. The sarsen stones produced the fundamental resonance, while the bluestones added harmonic complexity. Together, they created an acoustic environment that would have profoundly affected anyone who experienced it. Modern sound engineers design concert halls and recording studios using similar principles, positioning reflective and resonant materials in calculated locations to shape the acoustic character of a space. Stonehenge applied the same principles with 25-ton stones, positioned with accuracy measured in centimeters. But Grok's most shocking revelation came when it analyzed the wider landscape around Stonehenge. The AI was given access to LiDAR surveys, geophysical mapping data, and archaeological records covering the entire Stonehenge landscape, an area spanning several square miles. What Grok found in this data completely changed the understanding of what Stonehenge really was. The monument did not stand alone. It sat at the center of what Grok identified as an integrated ritual landscape containing hundreds of features, earthworks, burial mounds, processional avenues, timber circles, and pit alignments, all positioned according to geometric and astronomical relationships that the AI algorithms detected and measured. The AI mapped the location of every recorded archaeological feature within a 3-mile radius of Stonehenge. It then analyzed those positions for mathematical relationships, geometric patterns, and astronomical alignments. What it found was that the entire landscape had been organized according to what modern surveying would call a control network, a system of precisely placed reference points maintaining geometric relationships across long distances. Specific burial mounds occupied positions that formed perfect triangles, with Stonehenge at the apex. Other earthworks aligned along straight lines stretching for miles. Timber circles occupied locations marking specific astronomical events when viewed from Stonehenge. The entire landscape had been designed as a unified system, with Stonehenge acting as the central node in a network of monuments extending across the surrounding countryside. Grok calculated the surveying precision required to create these landscape-scale geometric relationships. To position monuments miles apart with geometric accuracy measured in feet would require surveying methods, measurement standards, and mathematical abilities traditionally believed not to have developed until classical Greece, 2,500 years later. Yet the physical evidence recorded in the LiDAR data shows that Neolithic people achieved exactly that. Dr. Sarah Bradford, an archaeologist specializing in landscape analysis, reviewed Grok's findings and said the AI had revealed patterns that human researchers simply could not detect by examining individual sites in isolation. When the landscape is analyzed as a system, it reveals design principles and planning abilities that challenge everything we thought we knew about Neolithic social organization and technical knowledge. But this is what makes the discovery so haunting. Grok found that the landscape organization included features that predated the sarsen stones at Stonehenge by centuries. Some earthworks and burial mounds that participate in the geometric network were built between 3,500 BC and 3000 BC, roughly 500 to 1,000 years before the main sarsen circle was erected. This means the landscape scale plan came first, and Stonehenge was later built to fit into a pre-existing system of geometric relationships. Consider what that implies. Someone conceived a plan to organize monuments across several square miles of landscape according to geometric and astronomical principles. They began implementing that plan around 3,500 BC. Centuries later, their descendants or successors positioned the sarsen stones at Stonehenge to satisfy specific requirements within that ancient plan. This represents continuity of knowledge and purpose across at least 500 years, spanning 20 to 25 generations of people who somehow preserved the plan without written records. Or did they have written records? Grok cannot tell us that. But it can show that the physical evidence requires either a written plan, a symbolic recording system of comparable sophistication, or an oral tradition capable of preserving complex mathematical and astronomical information across centuries with minimal loss. The AI then analyzed something that has always troubled researchers: the construction sequence. Grok examined radiocarbon dates, architectural relationships, and stratigraphic sequences to reconstruct the order in which different elements of Stonehenge were built. What it discovered followed a disturbing pattern we have seen elsewhere. The earliest stone complexes at Stonehenge displayed the highest degree of astronomical and acoustic precision. The initial bluestone arrangements demonstrated a sophisticated understanding of harmonic relationships. The first sarsen trilithons achieved optimal acoustic resonance. Then, in later construction phases, the precision declined. Stones were rearranged in ways that weakened the acoustic properties. Alignments became less exact, and the overall quality deteriorated. This is the opposite of what one would expect from a civilization learning and developing new capabilities. Technology should improve over time as knowledge accumulates and techniques are refined. But Grok's analysis suggests that Stonehenge reached its peak sophistication early, then began to decline. This implies that the builders were not inventing the knowledge. They were applying knowledge they already possessed, knowledge that had already begun to fade. Grok quantified this decline by measuring the deviation from optimal acoustic positioning across the entire construction sequence. The earliest stones deviated from their ideal acoustic positions by an average of 1.26 inches. Later stones deviated by 5 inches. Precision declined gradually over time, as though each succeeding generation of builders understood the principles slightly less than those who came before them. But the AI made another discovery that deepened the mystery even further. When Grok analyzed the geological evidence for how the sarsen stones were shaped and positioned, it found something that should not have been possible with Neolithic technology. The contact surfaces where the stones meet, where the uprights support the lintels, and where the lintels join together to form the ring, display machine-like precision. Modern stonemasons examine the high-resolution photogrammetry data, under the guidance of Grok's analysis, and confirmed what the AI had detected. The stone surfaces were not roughly shaped and then assembled. They were precisely crafted to create custom three-dimensional interlocking joints. Some surfaces showed curvature variations of less than 2 millimeters across sections, measuring nearly 20 inches in length. This is a level of precision normally associated with metalworking tolerances, yet it was achieved on stone using tools made from stone, antler, and wood. Experimental archaeologists have attempted to reproduce this degree of accuracy using authentic Neolithic tools. Skilled craftspeople working for months have managed only rough approximations, nothing approaching the tolerances measured by Grok in the original stones. The AI reached a clear conclusion. Either the builders of Stonehenge possessed techniques that we have not yet identified and cannot reproduce, or they had access to more sophisticated tools than the archaeological record currently suggests. Grok also examined a curious pattern that researchers had documented, but never fully explained. Certain sarsen stones show evidence of having been worked at different times using different techniques. The AI identified distinct signatures within the tool marks, patterns indicating separate methods applied to the same stone. In some cases, weathering analysis suggests these episodes may have been separated by decades or even centuries. This means some stones were partially shaped, left untouched for long periods, and then completed later using different methods. Why? Grok's algorithms suggested a possibility that is both elegant and unsettling. The stones may have been worked by people with only partial knowledge of the original techniques, individuals experimenting with different approaches while attempting to recreate a level of precision they could still see but no longer fully understood how to achieve. Perhaps they were studying earlier stones, shaped by predecessors who possessed greater skill and trying to match that quality using whatever methods they could devise. Sometimes they came remarkably close, other times they fell short. The physical evidence preserved within the stones themselves appears to tell a story of declining capability over time. The AI's analysis of the astronomical alignments revealed something equally profound. Stonehenge is famous for its summer solstice sunrise alignment. On the longest day of the year, the sun rises directly above the heel stone, and its light enters the monument along the central axis. Grok confirmed this alignment, but it also detected 8 additional astronomical alignments that human researchers had overlooked or dismissed as coincidence. The AI found that specific stones marked major lunar standstill positions, the extreme points of the moon's 18.6-year cycle already encoded within the Aubrey holes. Other stones aligned with the rising and setting positions of specific stars as they would have appeared 5,000 years ago, taking precession into account. Some stones marked the cross-quarter days, the points midway between solstices and equinoxes that appear in many agricultural calendars. What makes this remarkable is the level of precision. Grok calculated the accuracy of each alignment and found an average error of less than 0.3 degrees. Achieving this would require years of observing celestial events, systematically recording those observations, calculating precise rising and setting positions while accounting for horizon elevation and atmospheric refraction, and then translating those calculations into stone placements accurate to within a few inches across distances of hundreds of feet. Modern archaeoastronomers rely on sophisticated software, precision surveying equipment, and detailed astronomical databases to calculate ancient alignments. The builders of Stonehenge achieved comparable accuracy 5,000 years ago using methods we cannot identify. Grok can measure what they accomplished, but it cannot explain how they achieved it without advanced tools, without writing, and without centuries of recorded astronomical observations. Unless they actually possessed centuries of accumulated knowledge. Unless Stonehenge represents not the beginning of astronomy in Britain, but its culmination. The physical expression of knowledge gathered across generations, perhaps even millennia, and finally encoded into permanent stone. The AI discovered something else within the astronomical data that is deeply unsettling. Some of the alignments identified by Grok do not mark single events. They mark cycles. The lunar standstill positions repeat every 18.6 years. Some stellar alignments complete full cycles only after centuries because of precession. The monument was not simply a calendar marking annual events. It was a mechanism for tracking long-term astronomical cycles spanning decades and centuries. Why would Neolithic people need to track cycles longer than a human lifetime? What purpose would be served by encoding astronomical patterns that require multiple generations to complete? Grok cannot answer those questions, but it can demonstrate that the capability exists within the stones. The AI's analysis of the site's abandonment around 1600 BC revealed patterns suggesting that this was not a simple cessation of activity. Grok examined the final phases of activity at Stonehenge, the last stones positioned, the final cremations deposited, and the last modifications made to the monument. What it found indicated clear evidence of preservation rather than abandonment. Fallen stones were not re-erected. Instead, they were carefully laid upon the ground. Certain areas were deliberately filled with soil in ways that protected buried features from erosion. The site was not destroyed, vandalized, or casually deserted. It was carefully closed, as though the people responsible understood that they could no longer maintain the monument, but wished to preserve it for some future time. This is the behavior of people who know knowledge is being lost. They can no longer sustain the traditions, no longer use the monument properly, and no longer pass on a complete understanding to their descendants. But they can protect the physical structure itself, ensuring that even if the knowledge fades, the monument remains, perhaps carrying information that future generations might one day decipher. That future generation is us, and the decoding technology is Grok. When Grok analyzed all of its findings together, the lunar mechanics encoded in the Aubrey holes, the acoustic engineering of the stone circle, the harmonic properties of the blue stones, the landscape scale geometry, the astronomical alignments, the construction precision, and the pattern of declining capability, it identified a single unifying principle. Everything at Stonehenge revolves around cycles. Lunar cycles are encoded in the spacing of the holes. Solar cycles are marked by the alignments. Acoustic cycles emerge through resonant frequencies. Long-term precessional cycles are tracked through stellar alignments. The monument appears obsessed with cyclical time, with repeating patterns, and with events recurring across intervals ranging from days to millennia. Why such a focus on cycles? Grok's pattern recognition algorithms compared Stonehenge's cycle tracking capabilities with similar patterns found in other ancient monuments around the world. These sites also demonstrate sophisticated astronomical knowledge, also track long-term cycles, and also appear designed to preserve information across generations. The AI detected correlations suggesting a shared purpose. These monuments may have been built to track, predict, and perhaps even warn about recurring catastrophic events. Climate cycles, solar cycles, and celestial mechanics that could influence conditions on Earth. The builders of Stonehenge and similar monuments may have understood that catastrophic events follow patterns, recur according to schedules, and unfold according to astronomical cycles that can be calculated and predicted. They encoded that knowledge in stone, because stone survives the centuries separating one cycle from the next. This remains speculation, and Grok explicitly labels it as such, but the AI can demonstrate that long-term cycle tracking existed at Stonehenge, that the monument was designed to preserve astronomical and mathematical information across centuries, and that its builders went to extraordinary lengths to encode knowledge in the most permanent medium available to them. What knowledge were they trying to preserve? What cycles were they tracking? What events were they attempting to predict? Those questions remain unanswered, but Grok's analysis makes one thing clear. Stonehenge was more than a temple, more than a calendar, more than any single-purpose structure. It was a repository of knowledge, information encoded in stone, mathematics expressed through megaliths, and astronomical data preserved within the physical positions of rocks that have stood for 5,000 years, waiting for a civilization advanced enough to read what was written there. That civilization is us. The technology that finally deciphered the code is Grok AI, and what we have discovered is both humbling and disturbing. Humbling because it suggests that our ancestors possessed knowledge and capabilities far beyond what we have traditionally credited to them. Disturbing because it suggests that this knowledge was already being lost, while Stonehenge itself was still under construction. That we may not be witnessing the birth of astronomical science, but its decline. A final desperate effort to preserve understanding before it disappeared into oblivion. What do you think? Are we looking at Neolithic people taking their first steps toward astronomical knowledge? Or are we looking at the remnants of an understanding that was already ancient when the stones were raised? Knowledge encoded in the only permanent medium available, preserved for whoever would eventually develop technology sophisticated enough to decode it. This is not speculation. This is data analysis. This is Grok AI processing centuries of measurements, surveys, excavations, and research to reveal patterns invisible to human observation. The mathematics is there, the astronomy is there, the acoustic engineering is there, the geometric precision is there, all of it recorded, measured, and verified. The truth about Stonehenge is that we are only beginning to understand what it really is. It is not a simple stone circle built by primitive sun worshippers. It is a sophisticated repository of knowledge encoding astronomical, mathematical, and acoustic information at levels requiring capabilities we do not believe existed 5,000 years ago. Grok has shown us what is there. The question is whether we are ready to accept what that knowledge may represent and where it truly came from.